Okay, hope everyone had a good spring break. Got away from school for a little bit and kind of just got to, like I said, get away from school. Hope everyone's doing okay after the crazy weather came through last night too. Um, so we're going to start hyperbolas today, okay? Probably the toughest section out of all of them, okay? We're going to have a couple assignments this week. We're going to do another day of hyperbolas. I'm going to upload it. I'm going to give you guys time to work on tomorrow, and then I'll probably upload like Wednesday or Thursday and let you work on that through the weekend, okay? And then we're going to start building towards some sort of assessment here in the next couple of weeks over all the different conic sections. So we're going to go back over some stuff next week and the week after that, and then I think we'll have some sort of assessment. But like I said, again, guys, I just really miss all of you so much. I hope you're all doing okay. Please feel free to send me messages, over Reminder, emails to tell me how you're doing. I just thank you for all the hard work you're continuing to put in and completing the assignments and stuff. We only got a couple more weeks left together, so wish they were in person, but we'll just make the best of what we have and yeah, just go from there. So, all right, so with hyperbolas, we're going to see some of the same with the formula as ellipses, but a little change, okay? So let's go over some definitions real quick. So the center, okay? The center is still going to be h comma k, like it's always been, okay? It's always going to be h comma k. All right. And so the definition is this is the intersection of the transverse and conjugate axes. Now, I know we've been using major and minor. Transverse is another word for major. Conjugate is another word for minor. Okay? All right, vertices. Okay, vertices. The definition of that is the intersection. It's the intersection of the transverse axis axis and the curve. Okay. Again, A is the distance from the center to each vertex, same as applied. So I'm not going to write that down again because we already talked about that on ellipses. Okay, so that's where you get a common thing. So A is equal to the from the center to the vertex. Okay, the distance from the center to each vertex. Sorry, brain fart there. Okay, so let's talk about foci. Okay, this time again we've got two focuses, same like we did with ellipses. Foci is the singular term for it, or I'm sorry, is the term for multiple focus. Okay, so again, what we know about the foci is that it's on the transverse axis. Okay, on the transverse axis, inside, and it's going to be always inside the hyperbola. Okay, so inside the hyperbola. C again is the distance from the center to each focus. Okay. So C is the distance from the center again, so we need to write that. Okay, now we do have one new thing. We do actually have asymptotes, and they're actually slant. So I write that out there, slant asymptotes, and we'll talk about how to graph those shortly. Okay, but again, the definition of an asymptote is a line, or in this case, lines that the hyperbola approaches the hyperbola approaches but does not cross. Okay, but does not cross. All right, so let's go ahead here and let's kind of give you a picture so you kind of have an idea of what to expect here. Okay, so let's just do a point right here in the middle. This is going to be our, it's going to be our center right here where we're starting. So H comma K. Okay. Kind of go both sides here, do the best we can. Okay, and at the end of these are going to be our vertex. Okay. All right, and then that means we would go up. And the reason why I'm drawing a line here is just so you can kind of see where these are. So from here that's A. That's B, okay, and then we'll get to the focus here shortly, okay? All right, we're going to draw a, we'll talk about this shortly here, why we're doing this, okay? We're going to draw a magical box here. Dash line, this is going to help us with our slant asymptotes, which we will have a formula for as well, okay? Again, now, how did I get to this box? Just think about this picture right here. How did I get to these corners? I just went up B over A, right? Or down B over A, or down B over A, okay? And we'll talk about that more here shortly, all right? Through the corners of the boxes is our slant asymptotes. So that's why we're going to draw this magical box. We'll talk about this shortly, why we do that, because it helps us to draw our hyperbolas. We just drew them through each corner. Okay. Now, where's the actual hyperbola part? It's right here. Okay. So from the vertex, you just draw. If it's a horizontal hyperbola, you just draw parabolas going out to the left and to the right. Okay. There's no drawn ever at B, okay, so really that's why we only really care about the transverse axis, so in this case the major axes, okay, there's nothing ever drawn at B. Only if we had a vertical hyperbola would we then draw stuff going out here from these co-vertice points. And I don't even label co-vertices with hyperbola because, again, really, the only reason why you need B is to help you draw your slant asymptotes, okay? Now, where is our focus? Our focus is always inside the hyperbola, like we talked about, always inside. Okay? And so, if we were to do the distance from that would be C. Okay? So the distance from the center to the focus, that's C. I know there's a lot going on here, okay? So let's just recap real quick, okay? So how do we get our vertices? It's the distance from, it's just A. The vertices is A because it's the distance from the center to the vertices, okay? Our co-vertices, which we're going to need to help us draw our imaginary box with our slant asymptotes, is just B, just the distance from the center to the co-vertices, that's B, okay? And then the center to the focus, that's C. The center to the focus on both sides, that is C. Okay? All right? Our transverse axis is always our major axis. Okay? So this time on this, the transverse axis here, guys, is horizontal. Okay? and the conjugate this is vertical in this one. Okay, and then real quick again, kind of like what we talked about and we'll need this going forward is our transverse axis is equal to 2a, our full conjugate axis is equal to 2b. Okay? All right, if you notice here now, this is our formulas for a hyperbola right here. The only thing that has changed, well, there's a couple of things here. The only thing that has changed from just looking at the formula straight off is that now instead of having a plus between them like we had for ellipses, now we have a minus. Okay? Now we have a minus. All right? Now, how do we determine where a squared and b squared is? Well, with ellipses, okay, ellipses, remember, with ellipses, a squared was always bigger than b squared. Okay? So the ellipses, a squared was always bigger than b squared. With hyperbolas, it's not the case. If you look at this second part right here, if you look at that second part right there, see how there's a negative in front of this whole fraction right here? B squared is always right of negative sign. Okay? B squared is always to the right of the negative sign. Okay? It doesn't matter anymore whether one is bigger than the other. Okay? That doesn't matter. There will be cases where you have a longer conjugate axis than you do transverse axis. And that's just because B is bigger than A. Okay? And that's okay. That's okay. So again, look at here again. When I circle this fraction, the negative sign is always to the right of b squared. The negative sign is always to the right of b squared. Okay? Our vertices are always on our transverse axis. Okay? So when the negative sign to the right of b squared, when y is to the right of the negative sign, we know then that the transverse axis is going to be horizontal. Okay? When the negative sign is to the right of the x here, we know that the transverse axis then is going to be vertical because now a squared is under y. Okay? So just ask yourself, where is a squared under? When a squared is under h, it's a horizontal transverse axis. Okay? When a squared is under y, it's a vertical transverse axis. Okay? Again, go ahead, follow all of our information here. This is how we find our stuff. Okay, you will have access to all these formulas. Okay, you will have access to all these formulas when we do have an assessment over this unit. Okay? Our eccentricity again is C over A. Okay, C over A. And it's always going to be greater than 1. Okay? Always going to be greater than 1. That's why the focus is on the outside. Okay? So C over A is always going to be greater than 1 when you do eccentricity. Okay? Now look at our new formula here to find C. Okay? With ellipses it was C squared equals A squared minus B squared. For hyperbolas, though, it's C squared equals A squared plus B squared. Okay? Here is our formula for the asymptotes. Guys, very simplistic. We'll talk about that as when we go over both of these problems here. Okay? Again, if you learn how to draw the imaginary box with B over A or A over B, which we'll talk about here when we get to the problems, it makes it really easy. Okay? When you find H and K and B and A, you'll just plug them into the formula as well, and we'll talk about that going forward as well. Okay? So what I would do now is I would pause this for a second to get caught up before we continue on to the problems. Okay? All right. So, continuing on. Okay, continue on down here to number 1. Okay, so we've got x plus 1 to the second power over 16 minus y minus 1 to the second power over 9 equals 1. Equals 1. Okay, so my center is still always, guys, opposite h and k. So opposite h and k. Remember, h is with x, k is always with y. So it looks like my center is going to be negative 1, 1. Okay? Now, to do the rest of this stuff, we need to find a, b, and c. Okay? So again, recall though, based on our formula, okay, based on our formula, sorry, I'll scroll. Well, it's hard to do that, okay? You're just going to have to look back up yourself as I'm going over this stuff, okay? Because I want to make sure you guys can see this, okay? So the thing we need to find is we need to find a, b, and c, okay? So first off, where is a squared under, okay? Well, remember, a squared is under the term that does not have a negative sign in front of it. So in this case right here, we would say then a squared is equal to 16, which then we need to find a though. And how would you do that? We did that with ellipses. Okay, if you're having trouble, go back and watch that video again. Remember, take the square root of both sides, and so we find out then that a is 4. So if I know then that a squared is 16, then b squared has to be equal to 9. Again, the negative sign is in front of the y, therefore I know that that is b squared. If this was the negative sign in front of the x here, okay, then this would be b squared. The positive fraction is always a squared. The negative fraction is always b squared. Okay, so then if we do square root both sides, we find out that b then is equal to 3. Okay, to find c squared, we're going to use our formula. Our formula is c squared equals a squared, which we found to be 16, plus b squared, which was 9. So that's going to give you this now. That's going to give you now c squared equals 25, which then when we square root both sides, then we know then that c is equal to 5. Again, guys, all I did was I plugged it into the c squared equals a squared, which we already found. We said a squared is 16, b squared was 9. And then when you add them together, 16 plus 9 gives you 25. Square root both sides, you get c equals 5. Okay. All right, eccentricity is just c over a. So in this case, okay, c over a, so 5 over 4. Again, that is greater than 1. We always said our eccentricity with hyperbolas is going to be greater than 1. Okay. Our vertices, let's all our formula. Okay, so since the a squared is under, guys, since the a squared is under the x here, this is going to be a horizontal. That's going to be a horizontal hyperbola because the a squared is under the x. Again, we always, wherever that a squared is at, defines either horizontal or vertical. Okay, so then let's go to our horizontal transverse axis, all our formulas, and let's find what our vertices is. So our vertices formula is this. It's h plus or minus a comma k. So what was h equal to? We found h to be, so again, this is h, that's k, so we got -1 plus or minus a, which a in this case is 4, comma k, which is 1. Okay, and if you were to do -1 plus 4, that would give you 3, comma 1. And then if you were to do -1 minus 4, that would give you -5, comma 1. Okay, and guys, that's okay. You can leave it like this. Like I would prefer you to leave it like this, just so you don't maybe mess up your math. But if you want to write, this is me just writing it out after doing this math here: -1 plus 4, -1 minus 4, and then obviously k doesn't change because there's nothing being added or subtracted to it. Okay, same thing. Our foci. Okay, guys, again, the only reason why I'm not asking you for the covertices is because the only reason why you use that is to help you draw your slant asymptotes, and I'll show you that here shortly. Okay, all right, so foci right here, okay, foci, so our formula for the foci are going to be h plus or minus c comma k, all right, so again, h is equal to a -1 plus or minus, now what do we get for c? C is 5, comma k. Again, because this is a horizontal hyperbola, A and C are on that same axis together, just like with ellipses. Okay, just like with ellipses. All right, so if we were to go ahead and write out these points, -1 plus 5, that's going to give you a +4, comma k, which is 1, so 4, 1. Okay, and -1 minus 5, that's going to give you a -6, comma 1. So there would be our two focus. There would be both of our focuses right there, okay? All right, for our asymptotes, just plug in everything you know, okay? So you're like doing opposite of what you originally told me the center was. It's like just kind of go back to what you see in the original problem, okay? So y minus k. So what was opposite k when we wrote it out as the center? We had +1, so we're going to write it as y minus 1 equals, okay? since this is a horizontal hyperbola, it's going to be plus or minus b over a. So what do we get for b? We got 3 over a, which is 4. And then in parentheses, again, opposite from your center, right? So since it was a negative 1, it's going to be x plus 1. Okay, x plus 1. All right, let's go ahead and draw our axes again. I just do, since it's 20 by 20, I just do 10. I do 10 by, sorry, just draw your axes whatever way you need to fit it on the graph, sorry. Okay, so there's our y-axis. There's our x-axis, okay? All right, and let's go ahead here and let's start off with our center. So negative 1, 1. Okay? And we'll put a C there for center. Okay? All right, so we know we have a horizontal hyperbola here because the a squared is under the x. Okay, so we know then that I'm going to go to the left and the right of the center to put my vertices, and my focus. Okay, or my foci. Okay, my foci. All right, so there's our center. All right, so let's label both of our vertices. Okay, so all that means is I'm going right and left A. Okay, so from the center I'm going to go right 4. Okay, and I'm going to put a V there for vertex. And actually, let's do it on the inside actually. And then I'm also going to go left 4. Okay. Let's go ahead and let's graph our focus, or our foci. Sorry, I keep saying the singular word. I need to say the plural. Okay, so let's graph our foci. So our foci are just left and right from the center C. Okay, so left and right from the center C. So 5. Okay, let's put an X there. Put an X there, and we just put an F next to it. There's our foci. Same thing from the center. We're going left 5. Put an F there as well. Okay. Notice again, the foci are always outside of the vertex. Always outside of the vertex, and they're going to be inside the hyperbolas. Okay. Now, we're almost done. The only thing that we're going to need is yes, we do need to graph our co-vertices just to help us draw our box here. Okay. So remember my co-vertices. Okay. My co-vertices, which I didn't draw on the picture up there, are just B. So from the center up and down B, because the co-vertices are not on the same axes as the vertices in the foci, which we learned that with ellipses a couple weeks ago. Okay, so from the center, I'm just going to go up and down B. So I'm going to go up 1, 2, 3. Okay, I'll label that co-vertices here. Okay, and then I'm going to go down. Down 1, 2, 3. Okay, again, labeling the co-vertices, the only thing that's going to help me do, guys, is that's going to help me draw my imaginary box that help me draw my asymptotes. Okay, all right, so when we look at our formula, we see this plus or minus, okay, and since it's horizontal, B over A. So watch what happens here. I'm going to go up 3 to B, and I'm going to start drawing a imaginary rectangular box. Okay, and I'm going to continue to go over until I get on the same vertical line as the vertex. Okay, up B over A. Up B over A. Okay, and so you just draw that rectangular box through the co-vertices, and just be careful, don't do it through the focus or the foci. Okay, and so you kind of get a rectangular box like that. So I went up B over A this time because it's a horizontal hyperbola. Okay, up B over A. All right, down B over A. Okay, but yeah, you just kind of follow the pattern. So up B over A, and then as soon as we get to the same vertical line as the vertices, then we cut it down, and so you just kind of draw this way. And so by doing it accurately like this, you don't technically have to really worry about this formula. All you're going to do now is through the corners of the rectangle is draw your slant asymptotes that go through the center. Okay, so all I did was I started up here, I went through the corner, through the center, and I drew my first slant asymptote. Okay, now we've got another corner box right here, so we're going to start bottom left here. Slant asymptote through the corner box there, through the center, through the top right portion of the box, and continue up. And there you go. There is your slant asymptotes. Okay. Last but not least is starting at the vertex. Now you're going to draw the hyperbola part, which is just two parabolas turned on its side. Okay. So at the vertices here, I'm going to start and I'm going to swing up this way, going along the slant asymptote, but not touching it. Continue going down and slanting it this way as well. Okay, there's one. Okay, draw our second one here. Vertices going up. Going that way as well, and that's what kind of gives you that parabola shape, guys, because again, what's happening here is it's getting pulled. Our lines are getting pulled to that asymptote. That's what's giving you the parabola looking shape on both sides. Like that. Okay? All right. That should cover that. Let's look at now number 2. Okay, so number 2 now. First off, what's our center? Again, remember, H is with X, K is with Y. Do not get confused here. Do not get confused here just because now Y is first, K is second. Remember, H is with K, H is with X, sorry, K is with Y. So opposite of that 5 is going to be a negative 5. Okay. Opposite that negative 3 is going to be a 3. Okay, remember there's H. There's K. All right. Now we need to find A squared, B squared, and then that will help us find C squared, which will then eventually help us find C. So first off, what is A squared equal to this time? Okay. Well, if I notice here, I see that the negative sign now is in front of, what is right of the negative sign is the X. Okay. So remember, B squared is always to the right of the negative sign. So in this case, then I'm going to label A squared as 4. Which then when I square root both sides, I'm going to get then A is equal to 2. Okay. B squared is equal to 25 then. Okay, remember, B squared is always to the right of the negative sign. Every time. And so when you square root both sides there, you're going to get that B is equal to 5. All right. Now to find C, we're going to use our formula. We're going to set it up. We're going to do C squared equals A squared plus B squared. So A squared was 4. B squared was 25. Which then that is going to give you that C squared is equal to 29. Okay. And then when we square root both sides, we're going to get C is equal to the square root of 29. Which let's approximate that because that's going to really help us to determine exactly how far we need to go up and down from the center this time. Okay, so just square root 29 and then use the approximate button down here and we got it to be, let's just round to the 10, so we'll say it's approximately 5.4. Okay, now when we do the eccentricity though, guys, I want the exact value, so C over A in this case, you would just write it as the square root of 29 over A, which is 2. Okay, so you just do the square root of 29 over 2, which I bet if you check that again in your calculator here, it will definitely be greater than 1. So square root of 29 over 2, approximate that, and there you go, yeah, greater than 1. Always should be, eccentricity is always greater than 1 on hyperbolas. Okay, now, this time, guys, because A squared is under the Y, we now have a vertical hyperbola. So what that means is that my transverse axis is now vertical, which means my foci and my vertices are going to, how do we find them? We're going to be going up and down from the center because I've got a vertical hyperbola now, which means I've got a vertical transverse axis. Okay? So let's go ahead and let's look at our formulas looking at the vertical transverse axis. If you just look up above there, okay? So to find our vertices, that's going to be h, comma, k plus or minus a. So again, h is -5, comma, k, which is 3, plus or minus, in this case, a, which is 2. All right, and so if we were to actually find those points there, we do -5, comma, 3 plus 2, which is 5. And then we would do -5, comma, 3 minus 2, which would be 1. So that would be our 2 vertices right there. Okay? Foci is a little bit more difficult because we're dealing with a radical expression here. Okay? And so again, what was our formula though for our foci though? It's h, comma, k plus or minus c. So h is equal to a -5, comma, k, which is 3. And then now c is plus or minus square root 29. Okay? And guys, you can just leave it like that, or if you wanted to, you could change that to 5.4 and add and subtract it, but I'm totally fine with you guys just leaving it like that. Okay? All right, my asymptotes, let's use our formula. Okay, it's y minus k. So again, opposite of k there, we're going to get y minus 3. Okay, equals plus or minus. Now this time, because we have a vertical hyperbola here, it's going to be a over b. A over b. So a is equal to 2 over b is 5, parentheses, and then it's just x minus h again, so opposite. So opposite of -5 is going to be a +5. Okay? All right, let's go ahead. Let's draw our axes. Okay, so let's go ahead here and let's start off by our center here. So -5, 3. Okay, so there's our center. -5, 3. Okay, this time here we've got a vertical hyperbola. So I'm going to go up and down a for my vertices here because it's vertical. Okay, so a is 2, so up and down. So there's 2. Vertices up 2, down. Okay, so there's our 2 vertices there. All right, our foci, same thing, are on this same line. So we're going to go up and down from the center there. Okay, 5.4, so just do your best. Okay, there's our focus right there. There's 1. And then we're going to go down from the center, 5.4 as well. Okay, so there's our focus. Now, the only reason why we're going to do our co-vertices is to help us draw our rectangular box, to help us draw our slant asymptotes. Okay? So our co-vertices, our conjugate axis is going to be left and right B this time because our transverse axis is vertical. So we're going to go over co-vertice there. And then I went left 5 as well from the center. Okay? Now, again, what was our asymptote? Up A over B. Up A over B. So start at the vertices right here and start drawing your rectangular box. Again, guys, look where I cut it down at. I cut it down. I started up here at the vertices. I went right B, down A, left B, right? So I just draw a nice rectangular box that connects all 4 of those points, imaginary there, okay? Again, now through each corner here, I'm going to start top left and I'm going to draw my slant asymptote. Okay, so I started top left through the top corner, drew my slant asymptote through the center, down through the bottom right corner, okay? Same thing here. Bottom left to the center, through the top right. Okay? Now, just do your best here when you draw these now, okay? But now when we draw both our hyperbolas, remember, this is a vertical hyperbola. Wherever the vertices is at, that's how you go about drawing these. So we're going to start at the vertices here, and we're just going to kind of swing it out along the asymptotes there. Okay, there's one. Here's the other. Okay, again, they always come from the vertices, never from the co-vertices. You're never going to draw a hyperbola on the co-vertices, okay? If it's vertical, the hyperbolas look like parabolas opening up and down. If it's horizontal, they look left and right. Okay? All right, good work, guys. Okay, yes, this was kind of lengthy today. This is probably the hardest. If you get this down, guys, that it's pretty much smooth sailing going forward. So, I'll be available tomorrow to answer questions. And yeah, just keep up the hard work. And yeah, guys, I'll talk to you again next week. All right. Or actually, we'll have a lesson later on this week that I'll upload as well. Talk to you later. Bye.